114, we are going to talk about what a dilation is. Okay? And what you just essentially played around with in your activity was a dilation. Okay? So a dilation is a different kind of transformation. What does it do with our figure? So it's going to make our figure either larger or smaller. Okay, I need to put the computer away, okay? So we're taking notes. See what I did there?
This is going to be so much harder.
It's really not, you guys. It's really not. Actually, yesterday in my curriculum meeting, we talked about why don't we put chapter 4 first? Because it's like the most straightforward chapter out of all of geometry. But there's some like vocab and notation stuff that you don't know yet, so we can't. But just hold on. We have what's called a scale factor. We're going to use the letter K. Okay? It is the amount a figure is made larger or smaller.
Larger or smaller? He didn't do it this time. He didn't do it this time.
I didn't. Not this time.
Look there, just larger and smaller at the top. One's larger, and then one's smaller, and smaller, and then larger's larger. Don't worry, I got it. Imbecile.
Okay, so this is what I'm going to do. I'm going to draw you a little picture here.
I cannot draw that.
All right. So, like if this right here is my pre-image, that didn't work well. If this is my pre-image and this is my image, okay, let's say that this distance right here is 4 and this distance right here is 20. It's okay if you don't draw it. Like, I'm totally okay with it. But let's talk about what our scale factor is. What would our scale factor be?
20.
Nope.
That would be
Nope.
That would be
Oh, it's not 16.
It is not 16. It is 5. How did Natalie get 5? It was Sydney. Okay. We can take 20 divided by 4 to get 5. Okay, or 4 times 5 gives us a big 20. So we are either going to be multiplying by a number. Well, no matter what, we're multiplying by a number. Okay. We are going to have an enlargement, which means our shape is getting bigger, right? If our scale factor is greater than 1, we are going to have a reduction if our scale factor is
less than 1.
Hey. Okay. But literally, we are going to multiply by a number to get our new shape. Okay? Whether it be making it bigger or making it smaller. Okay? Okay. So, here we go. Top of the next page. Okay.
My chicken is
Was it?
it did taste
I'm
good.
so good for you. So when I make my chicken, I mix breadcrumbs in with my flour,
That's what I said, but all she did was like.
and it
season
makes it
like,
crispier.
Yeah, I don't. She did it with just like seasoning, and I was like, I don't just like breadcrumbs or something. And she's like, I don't know.
Okay.
So much better.
Now let's pretend I have a coordinate A at -1, 4. And let's pretend our scale factor is 20. What's happening is this coordinate is getting further away from the origin by a factor of 20. Okay. And, you know, scale factor multiplication. That's why we're doing this. Okay. What's our new coordinate? What's our new coordinate? -20, comma, 80. We literally multiply by the scale factor. Not this one.
I'm starting to get this.
I'm getting the hang of this here, guys.
You guys, not that big a deal. Not that big a deal. All right. In your folder, go to page 10. Okay. Now, what I want you to do. Oh, my dear people. You are driving me bonkers. Okay. So I'm going to take the time to plot A at -2, 3, B at 3, 1, and C at 0, -3. Could you also please take the time to plot those 3 coordinates? While you plot these 3 coordinates, I want you to think about this. Is our triangle going to get bigger or smaller?
Bigger.
Okay, bigger. How do we know it's getting bigger? Is what I'm hearing. Aaron, what did you say? K is greater than 1. All right. Now, our new A coordinate. If A is at -2, 3 for the pre-image, then our image, A is going to be where?
-4,
Oh my gosh.
You have to give me a warning.
I do. I'm sorry. How did you get -4, 6? We multiplied by our scale factor. Okay. B prime is at 6, 2.
That's what tall I am.
I believe that one. You're like pigs fly.
And C prime,
0, -6.
I'm gonna.
are you still thinking that this is going to be difficult?
Yes.
Okay, so let's talk about these shapes. Okay? From our center, aka the origin, each coordinate has doubled its distance from the origin. So notice how, however far away A is, now A is twice as far. You see that? However far B is, now B is twice as far. Okay? That is what is happening. Sound good?
Yeah.
Yeah.
Absolutely.
Do you have a question? K will never be 0. Thank you for asking that. Okay?
Wouldn't it just be 0 then?
Okay, I want to talk about this one real quick. Because I really like this picture. Could you plot these 3 coordinates for me, please? Okay. Now, we are going to have a larger image because K is 3. Now, where does A prime go? It is still 0, 0 because that's the center of our dilation. However, B prime is now going to be at 9, 0, and C prime is now at 9, 6. Now, what I really like about this is since one of the points is at our center, we actually have like our shapes overlapping, and we can see we have this visual of our proportional side lengths. We can literally see that the side length for our pre-image is 1/3 of the side length of our image. Do you see that? Our image side length is literally 3 times the length of our pre-image side. Okay? All right. I'm going to skip number 3. We're going to do number 4 and call it a day. Now, let's plot our coordinates for number 4. You are plotting the coordinates in number 4. Now, since K is less than 1, we are talking about our shape getting smaller and closer to the origin, okay? Now, Conway says divide. Technically, we are multiplying by 1/3, but to multiply by 1/3 is the same as dividing by 3. So this becomes -1, 1 for A prime, -1, -2 for B prime, and what? -3, 0 for C prime. Isn't he cute?
Oh my gosh.
So cute. Okay. So, this is, hey. This is what we're going to do. In your student journal, on page 114 and 115 to 116. There are the extra practice problems. That's going to be your homework.
I thought we were doing this.
So you just have time to get it done?
That is not what we're doing.
My legs are so bad.
We're not in 4-6.